Good afternoon, everyone. I'm Christian G. Teixeira. Our topic that we discuss is all about infrastructural bridge. And now, I will introduce you my co-members, Hans Cadeyona, John Kenneth Capuchon, John Patrick Tatad, Justin May Binavides, Ninian Joy Ulep, Patricia Santos, Inigo Miguel Carrion, and also Alexis Agagon. Before I proceed the introduction, I will discuss infrastructural bridge. Infrastructural bridge is a precondition for a strong economy which helps societies to thrive and people to prosper. Infrastructure bring people together, allowing them to meet, exchange idea, learn and development. This vision play a key role in our project, and we use our extensive expertise to ensure the sure project can contribute to enhancing society. Bridges are symbol of culture and are often the iconic part of infrastructure, both fascinating and appealing to the imagination. And now, in our introduction, a bridge is structured which is built over some physical obstacle, such as body of water, valley, or road, and its purpose it is to provide crossing over the obstacle. It is built to strong enough to safely support its own weight as well as weight or anything that should pass over it. Before beginning construction on the bridge, engineer needs to understand the problem at hand. First, why is the bridge needed? Second, how strong does it need to be for its extended use? I think these two possible questions to be answered of an engineers will do this project or planning to do this project. Because if you are professional or licensed engineers, you need to know the possible higher risks if you are take this project, because it's not easy to engineers will do this project. Thank you.
Good afternoon, I'm Patricia Santos and I'll be discussing about the first step of the civil engineering design process for bridge. Step 1. Recognizing the need for a bridge. Before starting or beginning the construction, engineers need to identify or recognize first why the bridge is needed. Being aware of this helps the engineers to know how strong the bridge should be and the limitations in accomplishing it. More than that, recognizing the need can also make the engineers think or wonder and may begin to ask themselves the real need for that project. Like, is it just designing or constructing a bridge? Or, in a more general sense, designing a means that will effectively help the transportation of the people in that area. By that, the engineers can come up with broader ideas or generate solutions that may extend beyond a bridge to meet the general needs in a more effective way. Some examples of why the construction of a bridge is needed is first, building a bridge to span a physical obstacle. Physical obstacle like bodies of water or most commonly a river. It may also be a valley or the area between two mountains. Also, it can be over another road or any obstacle that makes crossing difficult or impossible. Bridge is built or constructed so that people can pass over those obstacles without struggling. Next, expanding a bridge is needed because of an increasing traffic volume. An increase in traffic volume is a common problem nowadays. Because of this, the time people spend traveling takes longer than expected, causing workers or employees to be late in their job. The delivery of goods also gets delayed, and It brings stress and costs extra fuel the longer the vehicle gets stuck in a traffic congestion. Expanding the bridge helps in reducing the traffic congestion brought by the increasing traffic volume, which has already been proven in Vietnam, in which the road and bridge construction projects in 2013 said to have helped in decreasing the traffic congestion according to their Ministry of Transport. Lastly, repairing or rebuilding a bridge due to calamities or natural disasters that have struck the area like earthquake, tsunami, hurricane, or flood. These events have a high potential to cause damages in infrastructures like bridges. During these disasters, bridges are very important since they provide a vital link to areas that may provide help and resources to the people affected. That's why repairing or rebuilding a bridge is needed so that it can be prepared for future calamities or disasters that may occur anytime soon. That was step one, recognizing the need for a bridge.
Good afternoon, everyone. I'm John Kenneth Capuchon, and this time I will talk about the second step of the engineering design process, which is defining the usage of the structure. But for now, we will focus on bridges. So, first of all, why do we need a bridge? So, as what Patricia Santos said earlier, there are natural problems that exist in our environment such as physical obstacles like valleys, roads, or pwede rin yung mga bodies of water kagaya ng rivers. The problem is, it's hard to go through that obstacles, right? And most of the time, it's dangerous. An example for that is NLEX or North Luzon Expressway. Expressways are built for the purpose primarily of facilitating the movement of traffic at high speeds and in large volumes. So, bawal ang crossroads sa ganun because it's dangerous to intersect that kind of road. So, the possible solution is to build a bridge. Since we're now talking about a bridge, there are a few things that architects and engineers should consider before building it. So dito magsi-start yung second step, which is defining the purpose of the structure, whether it is just a pedestrian bridge or sometimes people call it pedestrian overpass. Or meron rin namang bridge that is mainly designed for cars and heavier loads. In this step, the client and architect should communicate well. Adding to that, the people behind this construction should consider the location where the bridge will take place, whether it is a rural or urban place. So, mahalaga yun. If it is urban area, just like NCR, of course, it means many people will use the bridge. So, it requires stronger bridge and also more budget for the materials. So, this data is really important for the architect to design an appropriate bridge so that the structural integrity of the bridge won't be compromised and to ensure the safety of its users. So, after all those considerations, the architect and engineers, together with the client, can now start the step 3, which is the project planning.
Good afternoon. My name is Alexis Agagon, and step 3 is planning. As you can see from what is presented, first is surveying, wherein you will perform an examination or an observation of a certain place for the project. You will have to decide the appropriate materials. For instance, there are some bridges wherein it is utilized heavily. Hence, the cost may be more expensive than bridges that are not usually passed by. These are some factors that you should consider in estimating the cost. First, first is estimate of cost of right of way or easement. Include supporting data. Second is estimates of cost for relocating public utilities within the construction area. Third is estimate of cost for removal of buildings and other structures within the construction area. Lastly is to provide any pertinent cost estimates or information that has been prepared. Also, one should consider various factors that may affect the infrastructure, such as the geographic location, the weather, if it's prone to typhoon or landslides, if it is at the epicenter, and more, which is in line with environmental considerations. Aside from the conditions of the environment mentioned, consistency with the Philippine EISS law or international standard, a comprehensive assessment and management program shall be made to address projects' specific risks and potential impact to the government. The potential environment issues are: first is threat to aquatic and shoreline environments. Second is hazardous material management. Third is wastewater. Next is air emission. Next is waste management. And lastly is noise.
Good afternoon, everyone. I am Ninian Ulep, and I will discuss the schematic design phase of the bridge, or step 4 conceptualization in engineering design process. Final surveying. Perform other surveys if needed. In this phase is where the beginning of making the initial bridge design. It is expected that there will be a lot of adjustments in designing, so mostly the engineers are making or considering alternative plans if the results from surveying are not enough. Review and checking of obtained data. This is crucial and really important because we are making sure that the results obtained from the several tests from surveying are accurate. There will be no room for mistakes. Updated data. Like from the previous slide, it is just a completion of data. This is really important because the design, calculation, and the construction of the bridge will be relying on the results from the compiled data. Schematic bridge layout. This is where engineers prepare multiple schematic bridge design in accordance with the specification and consideration collected from the data. So yung consideration pwedeng materials, yung cost, yung budget of the infrastructure. Evaluation of each proposed schematic designs. And ina-narrow down yung mga layouts at least 2 design. So, pwede nang mamili ng bridge type. Here are some examples of bridge designs. The selection of bridge type will be based on the results of data collection. Materials. Preparing the list, finding resources and its availability, initial estimation ng mga materials. So, it's just an initial calculation, preparation, dahil nagsisimula na tayo sa pagde-design. Dito rin nagsisimula yung initial calculation sa mga materials tulad ng strength, the capacity of the materials to withstand force, yung toughness or how strong the ability of the materials to resist from fracturing, ductility, estimate the degree to which the materials can sustain tensile stress before breaking, durability or gaano magtatagal yung strength ng materials, weldability or also known as jointability ng mga materials lalo na sa steel. Here are the usual materials used in bridges. So, yung stone, wood, and bricks, ito yung ginamit ng mga sinaunang tao. So, evident siya sa mga historical bridges. At dahil meron na tayong modern engineering technology, So, sa mga makikita nating bridges, gawa na siya sa concrete and steel. Meron na rin tong asphalt for the road construction para sa pavement, walkway, and roadway. Construction sequence. Dahil may initial design na and calculation, we can now create a milestone chart. It is to organize the process and to monitor the phasing of the construction.
Hello, so I'm Hans Cadayona from Group 3, presenting Design Development Phase, Step 5. So, first bullet point is finalizing layout, and the second bullet point is consulting the structural engineer. So, ang nangyayari dito is si architect will continue finishing the layout for the arc bridge, and after finishing that, i-consult na niya si structural engineer para malaman yung mga material sizes na gagamitin para doon sa arc bridge. Yun. So, next is after malaman yung mga material sizes na gagamitin para doon sa arc bridge, ay magpo-perform na ng mga preliminary designs. Si electrical engineer and interior designer ay magpo-perform ng preliminary designs. Katulad ng si electrical, ipo-perform niya yung parang kung saan nilalagay yung mga ilaw, mga tamang lugar na mga wirings, ganun. Para makita natin syempre yung dinadaanan natin dun sa arc bridge na yun. At sa interior designer naman, syempre, nakafocus lang to sa interior. Ang gagawin lang niya, syempre, yung parang design ng lapag, yung dadaanan natin, design ng parang interior ng bridge, yun. Yung mga bars, yung mga nasa gilid, yung mga sidewalk, ganun. Syempre, may sidewalk din yung arc bridge natin. Si contractor ay magpe-presenta ng mga estimated cost na galing doon sa project na yun, which is arc bridge. And after presenting the estimated cost, si architect ay makikipag-meet sa government. Since public infrastructure yung arc bridge, makikipag-meet siya sa government para mag-seek feedback ito para rin malaman yung thoughts ng government about dun sa ginawang preliminary designs dun sa arc bridge. Syempre baka kasi hindi sila satisfied pa dun sa ginawang preliminary designs, and para malaman din natin kung okay ba yung ginawa natin doon sa arc bridge na yan. So, syempre pag may kulang, kailangan ulit baguhin and makipag-seek ulit sa government para malaman ulit yung thoughts nila about dun sa arc bridge. And pag satisfy na sila, and then we will proceed to step 6. So that's it. Thank you.
So, good afternoon everyone. I'm John Patrick Tatad presenting Step 6 Construction Documentation phase of our proposed project Deck Arch Bridge. So, we came up with this idea na Deck Arch Bridge po yung gawin kasi feeling po namin mas convenient, mas maluwag, and mas kaya-aya siyang tingnan kaysa sa ibang design ng arch bridge. Kasi ibang design po ng arch bridge is yung arch po nila is nakaparallel or nasa taas ng bridge. And kapag ganun po yung case, nahaharangan po ng mismong arch yung view sa surroundings. Kaya mas pinili po namin na yung arch is nasa ilalim para malinis tingnan, and plus yung arch is yung magsisilbing support nung mismong bridge. Yan, parang double purpose. So, in this space, all the detail work is done. Construction document includes design specification and drawings from the architect. Civil and instructional engineers are finalized. Work of landscape architect may be included. The civil engineer provides the site plan design, which includes grading of the perimeter and area of the bridge, grading of the bridge, tension, compression, strength, etc. So, yeah. The structural engineer provides all the design details for structural components, including foundation, beams, columns, girders, connections, etc. So, dito po sa page na to, dito sa step 6, lahat ng documentation, lahat ng papers, lahat ng designs and layouts is finalized na ng mga engineer tsaka ng architect. Yan. Next, the structural engineer must bear in mind all the design specifications required by the building codes as established by local government. The construction document must be reviewed and approved by the inspectors. So, dito po sa page na to, lahat ng design, layouts, lahat ng papers, lahat ng documents is approved na ng mga nasa taas. So, construction na lang yung gagawin. Wala nang iba, approved na, wala nang babaguhin, finalize na lahat, gagawin na lang. So, dito po sa step 6 is makikita natin yung mga final designs nung bridge. So, ito po is yung nakuha naming final design ng proposed project namin na bridge. Yan, deck arch bridge. So, malinis po tingnan, kaaya-aya, and maluwag. Maganda tingnan. Yung nasa baba is yung top view ng mismong arch bridge. Mismong design po namin. Yan. So, next is yung construction procedure. Dito po, makikita po natin dito yung step by step na process, method, ways na gagawin ng mga workers para magawa ng maayos yung project. Ayan, ito po yung yan. Ito po yung itsura niya, yung nasa baba na shaded part is yung abutment. Yan. Kung saan siya yung nagsusupport sa mismong arch ng bridge. And yung arch ng bridge, siya yung nagsusupport dito sa mismong deck, sa mismong bridge, buong bridge. So, pwede po natin na rin siyang ma-consider na siya yung pinaka-support ng bridge kasi siya yung nagsusupport dito sa arch, and yung arch yung nagsusupport dito. So, pag wala yung abutment, walang arch ng bridge. Pero, lahat po sila is important dyan. Lahat sila is kailangan para makabuo ng isang bridge. Mas malaki lang yung role nito, ang dalawang to. So, ito po is tinatawag na girder. Ito po yung design nung design layout na girder na gagawin. Ito mong girder is matatagpuan po siya sa part ng deck. Ito po, papakita po sa ito pong nasa right side. Ayan po yung mismong itsura ng deck. Kung makikita po natin, ito yung girder na sa gilid. Yung dalawang bakal na makikita natin sa construction sites, yung dalawang bakal sa tulay, ayun yung girder. Siya yung pinaka-suporta, yung pinaka-skeleton ng mismong deck, mismong daanan. And kung makikita naman po natin sa left side, ito yung design ng beam. Ito po yung design ng beam, lahat ng specification, lahat ng measurements is nandiyan na, naka-indicate na po dyan. Yung beam, siya naman yung magsusupport dito sa tin plates. Yung tin plates, sila po yung bakal, yung flat na bakal, parang plywood, na nilalagay sa bridge para kung saan dun tatabunan ng mga ng mga simento, asfalto, para mga ganun po. Ayan. Ayan yung itsura nila. Ayan yung design. Final design. Next is yung mismong arch. Ito po nasa left side is semi-arch pa lang po yan. Kalahati pa lang. So, dalawa po sila, magkabilang side. Ang gagawin is, actually naka-build na po ata yan. And ang gagawin na lang is dadalhin sa mismong site. Kung saan, gagawin silang ganito. Katulad sa right side, gagawin silang vertically aligned sa mismong foundation. As I said earlier po, yung abutments, yung nasa ilalim, ayun po yung magsusupport dito. Doon po sila ilalagay para magsisilbing suporta dyan sa mismong arch. Tapos may mga cable po yan, hindi lang po masyadong kita, pero may mga cable po yan na nag-hold sa mismong arch para hindi siya matumba. Yan, kasi may process po yan eh. Ito po yung process niya. Ito. Yan. Sa step 4, ayun, vertical construction of arch ring phase 2. Ito po yung process niya kung paano siya gawin. Nakatayo na yung dalawang arch. And ang gagawin na lang is ang number 5 and 6, ilo-lower down yung mismong arch, yung dalawang semi-arch, para mag-meet sila dito sa gitna. Ayan, sa step 9. Pag nag-meet na sila dito sa gitna, parang ano po yan eh, Lego. Ganon. Babae, lalaki. Parang Lego na. Lego. Kung saan, yung puzzle piece. Yan. Doon na sila magbubuo. Doon na sila magdidikit. Ayun yung tinatawag na fixed point. Arch fixed point ng mismong bridge. So, ito po yung itsura niya. Next. Ito yung itsura niya. Ganito yung itsura niya. Pag nagdikit na silang dalawa, itong nasa gitna, yung fixed point, ay parang foundation ng mismong arch bridge. Yung abutment, support, itong nasa gitna, itong fixed point, yung foundation. Yan. Kapag nasira yan, tumba yung arch bridge. Yan. Kaya kailangan matibay yan. And next po is, yan, ito na. After po magawa yon, yung arch, after mabuo yung buong arch, may mga naka-ready na beam po doon sa taas nung mga arch. And ang gagawin po ng crane yung may mahabang tapos siya yung naglalagay ng mga column doon sa beam. Itong mga column, wherein yung beam yung magsisilbing support foundation ng mismong gagawin na deck. Yan. Siya yung magsisilbing foundation sa deck. And which is ito. Next. Yan. Ito. Yung deck, ayun po yung nasa taas. Ayun yung kanina yung binubuo ng girder, beam, tsaka yung mga plates. Ayun po yung deck. Yung mismong road. Mismong daanan. Yan. After that, mabuild na yung deck, yan, tapos na po. Final na. So, pwede na siyang siguro mga after ilang pwede na siyang maging accessible. Pero yun, final, ayun lang yung design pa lang po to. Yung mismong construction is nasa step 7 pa. Ayan. Ito lang po, yung lahat ng nasa step 6 is just only final designs, methods kung paano gagawin yung mismong bridge. Yan. Sana po naintindihan niya. Thank you.
Good day everyone, I am Inigo Miguel Igarion from Group 3 C11 S11 and I am here to tackle about construction administration phase or the CA phase. It is typically the longest phase and the most exciting part. It is when the project design and documentation is already done. In normal structures like buildings and houses, construction administration phase is another term used for double checking or revising. The main reason why is it depends to the client if they want to change something in order to finalize the product and to check if everything is going according to the plan. It is a little different when it comes to a bridge or an arc bridge to be specific. If you are a civil engineer and you work for governments, you need to consider decision of architect, structural engineer, and geotech. Here are some few things that we need to consider. First is the site condition. You need to inspect at least every day if the construction site is still in a good condition and safe for workers. I always remember that the capital ABC, always be careful. Then the second one is the geotech analysis. We understand that we need to consider the structural architect and civil engineer, and we also need to consider the geotech. So, geotech analysis. What is a geotech? It is a branch of civil engineering concerned with the behavior of earth materials. Is it important? Yes. Soil and rocks are the starting and the ending point of your bridge. In order to know the strength of the rock or soil, you need to consider the decision or the geotech analysis. Question is, what if the starting point and the ending point of your bridge is not strong enough to hold an arc bridge? It is risky. That's why we need to consider the geotech analysis. Third is, of course, safety. As I said earlier, ABC, always be careful. Is it safe? Then it should be. You consider the structural architect and civil engineer and the geotech analysis. You need to consider them all in order to have a safe bridge or to be safe. Lastly is durability. No one can say for how long, but we can start making an abutment plan. What is an abutment plan? It is a process where you need to strengthen the bridge by supporting the underneath of it. It is discussed in the design of the bridge. And one little fact about Arc Bridge. St. Louis Gateway Arc, built in 1960s at 630 feet both width and its base. It has been standing for more than 50 years from now. It is made of stainless steel and it is known as the tallest arc bridge.
Good afternoon, everyone. This is Justin May Benavides from Group 3. So, as a concluding remark, this report presents an overview of our planning design process of infrastructural bridge. In order to build a device, component, or method that meets a human need, the engineering design process is the application of math, science, and technology where it helps the engineers to the identification of an issue and the implementation of a feasible solution, making the process of design and development less messy and more cost-effective. Bridge building appears to include innermost projects requiring the use of expertise in many engineering fields, including geology, civil, electrical, mechanical, and computer science. Then, it must be systematic to integrate the efforts of those concerned. With regard to the project, the initial plans are prepared, including the features of the desired bridge, the site information, and the resource requirement. The key to good design is knowing when to apply each of these to best effect in the design process.